We got a couple of ones. How'd you get it? Well, I don't understand what you did too. No. Okay. So let me show you a couple different approaches here. Let me not, because I really don't want to fix it now, guys. There. Okay. F of square root of 3. This is what you did, Holly? I mean, Abby? Why did I say that? Abby, that's what you did? Okay. So Abby actually worked this out and got what? 0? Okay. So if we trust her calculations, and a couple other people are saying yeah. Now, Alex, you did it differently. What'd you do? Alternative is to factor f of x. Now, I'll tell you what, though. This thing may be hard for you to factor. But let me ask this question a different way. When I'm asking you, is square root of 3 a 0 of the function? What I'm really asking is this. Is something a factor of the polynomial? Do you know what factor I'm looking for? I'll give you a hint. It's x minus something. X minus what? Square root of 3. Would you agree that's what I'm really asking? The book calls this something. The book calls this idea the factor theorem. It says, hey, square root of 3 being a 0, that's equivalent to x minus square root of 3 being a factor. Does that make sense to people? Now, how do I check if x minus square root of 3 is a factor? Well, I'll show you. We did it yesterday. How did we do it yesterday? We did it, yeah, we decided long division was a pain. Let's do synthetic division. And so if I want to check if x minus square root of 3 is a factor, I put square root of 3 right here. I do my synthetic division, and I check that I have, what? No remainder. But the nice thing is that tells me not only that x minus square root of 3 is a factor, but it also tells me that square root of 3 is a 0. Do you follow? Barbara, go ahead. Which test? Tomorrow? Oh my gosh. I don't even have... Back to our program. All right, so let me ask you guys this question. Is negative square root of 3 a 0 of the function f of x equals x to the 4th minus 6x squared plus 9? Negative square root of 3. Well, I guess what the factor theorem tells me is that's kind of like asking, is what a factor? What do you think? What factor do you think I want to look for here? Very nice. X plus the square root of 3. If that's a factor, that's the same as negative square root of 3 being a 0. Does this make sense to people? With me or no? Okay? So, let's check. I know we're going to get the answer, but let's practice anyways, because we want practice on this stuff. So I'm going to put what up here in the box? I'm going to put the thing that I think is a 0. I'm going to put the opposite of what the factor is. I'm going to put negative square root of 3. Sometimes students have to have a little trouble figuring out what goes up there. What goes here is easier. 1, 0, 6, 0, 9. And what are the instructions, guys? Add and multiply. Yes, thank you. We almost had a crucial error. Alex and Jenna say -6. Okay. So we get negative square root of 3, positive 3, negative 3, positive 3 square root of 3. And yes, this is too fast, I understand, but it is what it is. Okay? If I get the 0, what do I say? Yes. Yes. Okay. Moving on, I want to show you an example of a harder problem. Because there were some that were not so friendly. So let's ask this one. Is 3 a 0 of this polynomial? G of x equals 4x cubed minus 8x squared minus 11x minus 3. Well, what I can do is at least set it up for you. -3, you try it with 4, 8, -11, and -3, and you should get it. Okay? All right. When I ask this question, is 2x plus 1 a factor of this thing? By the way, I'm also asking, is blank a 0 of the function? And by the way, I'd like to pause and let you talk for 30 seconds to fill in the blank with someone near you. So let's see. Anyone have an answer here? I'm saying, is something a 0 of the function? Right? So, by the way, if 2x plus 1 were a factor, then when I'm trying to find the zeros, right, to find the zeros, we would write 0 equals 4x cubed minus 8x squared minus 11x minus 3, right? And if I knew that 2x plus 1 were a factor, it would be 2x plus 1 times whatever, if I knew that. And therefore, I can say that either this factor is 0 or this factor is 0, right? So I get the equation 2x plus 1 equals 0. Make sense? So that's the same as x being what? I guess I have 2 more steps to figure it out. I remember by the time I was getting to this stage of algebra, I really didn't have to write that out anymore. The last 2 steps I just did. I remember looking at 2x plus 1. You could solve that for 0 in your head, right? Move the 1 over and then divide. So you get -1/2. Are you guys with me? Okay. So I'm also asking in this problem, is -1/2 a 0 of the function, right? And so this is the first time in class I've demonstrated that fractions can also be zeros, right? We did a lot of examples of whole numbers. Oh, we also did another kind of number yesterday. What kind of number is the square root of 3? Irrational. Remember at the first day of class I talked about all these different kinds of numbers. Irrational numbers like the square root of 3, they're on the real number line. Whereas this one, what would you call -1/2? What kind of number is that? That's rational, okay? So square root of 3, that's irrational. And then it's good to understand these things, that there's a difference. But for rational roots, it's pretty easy to see what the factors are, okay? So anyways, I want to talk about how do you solve this kind of problem. Well, I guess I could use my graphing calculator, right? 4x cubed minus 8x squared minus 11x minus 3. Graph. Huh. Hey, do you think -1/2 is a 0 based on what I just did? That's really hard to tell, right? Let me zoom in. I'm going to press the zoom button, zoom in, see if this helps me at all. Mitch, you were talking about this. You were talking about the situation where the curve just kind of kisses the x-axis. The word is tangent. What do you think, guys? Right over here. There's negative 0.53. You guys with me? What do you think? How do you think we should answer the question? Is negative 1/2 a zero of the function? Hard to tell, right? Sure looks close. All right, let's talk about how we can do it using the mathematics we've learned. We want to use the remainder theorem. We want to see if the remainder is 0. But I want to say something about the factor theorem, okay? And for the factor theorem, what we're going to do is we're going to put something here, right? And then we're going to put 4, negative 8, negative 11, and negative 3. We're going to put those numbers there. The whole issue is, what do I put here in the box up here? Because, well, I'm saying 2x plus 1 is a factor, right? But if 2x plus 1 is a factor, there's another step I could do. I could factor 2 out of this. Really? Yeah. You could write 2 times some stuff. You know? Yeah, that's right. You could say x plus, but then what would have to go here, guys? 1/2. That's kind of nice. You see that? So 2x plus 1 being a factor is kind of like 2 and x plus 1/2 being factors. Are you with me? Okay, so let's go ahead and put what up here in the box? Let's put negative 1/2. That's the thing I think is a 0, and it's the opposite. I remember, Matt, you were asking about c, and it always says x minus c. My c, if I write x plus 1/2, that's x minus negative 1/2. So c is negative 1/2. That's what I put here. And so now I'm going to go ahead and add and multiply, right? So Wayne, you were asking about this, right? What's the first step?
4.
Bring that 4 down. And then 4 times negative 1/2 is going to be what? Negative 2. Okay? So I have to keep track of my signs, and I have to just multiply correctly. And then what am I going to do? We add, and we get negative 10. So far, so good? For a reason. I'm begging it to pause. Okay, where are we at? Positive, when I multiply, it's going to be positive 5. And now I add, and what do I get? Well, adding is a tug of war. I get negative 6. And now I multiply again. Negative times negative is a positive what? Ha! Ha ha! You just feel great when you see that 0, you know? Because that means what? It's a 0. What else does it mean? What's a factor? It means, yeah, it means 2x plus 1 is a factor. Okay? So, how would I do this now? Well, I could say that 4x cubed minus 8x squared minus 11x minus 3 is equal to, well, I have to be careful here. Because what the black really tells me is that my polynomial is x plus 1/2 times what? Well, I get that from these numbers, right? I get the other piece from these numbers. So what would we write in there? 4x squared. That's right, because you got to get back 4x cubed. So that 4 is a 4x squared. Then minus 10x, and then minus 6. Okay? But, moving on, you guys were trying to tell me that I want to write it as 2x plus 1 times something. I could do that. There's just an intermediate step. I need to take a 2 out of here. Out of where? Well, out of here. Take the 2 out of the second term. The second factor, I mean. And so I get 2x plus 1 half. And then when I take the 2 out of here, I have 2x squared minus 5x minus 3. So I guess if I wanted to factor it, one way to do it is like this. Another way to do it is with a fraction, but we don't like the fractions, and so this shows that 2x plus 1 is indeed a factor. Barbara, go ahead. X to the fourth minus 6x squared plus 9 is a polynomial. And I want to tell you that we can try to divide by x minus the square root of 3. Now, you might remember last time I showed you that you could set this up as a long division problem. X minus the square root of 3. Right? And so you could write x to the fourth plus 0x cubed, if you want, minus 6x squared plus 0x plus 9. And this would be called long division. Long division. Hey, and how would you know if this x minus the square root of 3 is actually a factor of that polynomial? How would you know? Okay, I showed this last time once. It's only been one example. You would know it's a factor. Here, guys, how about this? What if I do 311 divided by 7? Now, I don't know if 7 goes into 311, but if I did the long division, how would I know if it goes into it, if it's a factor? The remainder. The remainder would have to be what? Same thing here. If the remainder is 0, then it's a factor. Well, long division has one problem. It's long. So instead, there's a trick that some of you may have seen before, and I'm very curious. Can you give me a show of hands if you've seen something called synthetic division? Good for those teachers. Now, if you haven't, I'm going to give you a little run through of how this goes. Instead of writing out the whole thing like this, we want to make it shorter tonight. So what you do is, usually there's a little box here. And what I'm going to do is, I'm going to put a number here. You know how it's going to say x minus something? Well, that's the number I'm going to put here, square root of 3. If it says x minus square root of 3, you put square root of 3. What if it says x plus 2? What do you put? Negative 2. You put the opposite. And the reason you put the opposite is because we want to do adding and multiplying. And normally when you do long division, there's a step where you have to subtract. I don't want to subtract. I want to add and multiply. So let me write this out. And I'm going to draw a line right here. And it's very simple now. I'm going to add and multiply. Add, multiply. Over and over again. Watch how this works. What's 1 plus 0? Nice job. 1. I added. What's the next step? Multiply. What's square root of 3 times 1? What's the next step? Add. 0 plus square root of 3. Multiply. Square root of 3 times square root of 3. Yeah, it's square root of 9, which is 3. Add. What's negative 6 plus 3? Negative 3. Square root of 3 times negative 3 would be negative 3 square root of 3. Let me add negative 3 square root of 3. Let me multiply. Now that's a little more work, right? So let's see, what do you get when you do negative 3 square root of 3 times square root of 3? Negative 3 times 3 is what? Negative 9. Hey, that's nice. You know what that means? I get 0 for my remainder. That's really nice. And what that means is we can always write P of x equals D of x, that stands for divisor, times Q of x. What do you think that stands for? Nice. Quotient, plus R of x, which is remainder. So the remainder is 0, right? That's 0 in my example. So what I just learned from my little work here, let me put it up here where you guys can see it. What I just learned is that x to the 4th minus 6x squared plus 9, that was my polynomial, is equal to, what's my divisor? X minus the square root of 3 times, do you guys know what to put here? And then I'm going to put plus 0 for the remainder. I guess the question is, do you know what to put here? Well, what goes there comes from these purple numbers right here. So the leading coefficient of my polynomial is going to be what? Even before that, I have a 1 here, see it? What am I going to put? 1 times what? It has to be x to the 3rd, because the original polynomial, the leading coefficient, the leading term was x to the 4th. Does that make sense to people? It's going to be 1 degree smaller. Do you see that? Okay? So I get x to the 3rd plus, well, square root of 3 x squared. Then what? Minus 3x. And then what? That's called the, what's that term called? The constant term. That's right. So this is what you can do with synthetic division. All right? There are some other situations we'll have to deal with, but I want to get you back to your exams before we run out of time. I'm going to stop. Nice work today.